So for these linear functions represented in these tables, we're going to be able to write the equation of the line. All right, and remember that is f of x or y equals mx plus b. This represents my rate of change, and the b value represents my y-intercept. Okay, so first off, we got to figure out what is the rate of change. So the x's are going up plus 5, then plus 5, then plus 10, plus 10. Okay? The y values, down by 4, down by 4, down by 8, down by 8. Okay, so the rate of change, let's make sure they're all the same. All right, here it's negative 4/5. Here is negative 4/5. Here's negative 8 over 10, which equals negative 4/5. Here's negative 8 over 10, which simplifies to negative 4/5. So my rate of change, my m value, is negative 4/5. All right, so as of right now, we can write f of x equals negative 4/5 times x. All right, now we got to figure out what the y-intercept is. Remember, the y-intercept is where the x-coordinate is 0. We need to figure out what the y-coordinate is at that point, okay? So sometimes we may have to work for our y-intercept, but we should first look at our table and see, are we given when the x-coordinate is 0, okay? We are, right in this first box, okay? So the b value is 18. That's my y-intercept. So I've got negative 4/5 x plus 18. That is my linear function here. Y equals negative 4/5 x plus 18, or f of x, whichever one. Okay, we have our rate of change, and then we also have our y-intercept. What about in b? In b, our x values up by 1, up by 3, up by 2, up by 5. Okay, and my y values up by 2, up by 6, up by 4, up by 10. Okay, so my rate of change, 2 over 1, which equals 2, 6 over 3, which equals 2, 4 over 2, which equals 2, 10 over 5, which equals 2. All right, the change in y over the change in x, those are all the same. So my slope, or my rate of change, is 2. Okay, so right now we could say f of x equals 2x. Now we just got to figure out the y-intercept. Okay, we don't have our y-intercept from this table. Okay, we need to work backwards to find it. I need to go back by 1 so that I'm at 0. I'm going to create another table here. Okay, I'm going to go back by 1 to go to 0. So from 0, what do I have to do to go backwards? All right, so for every change in x, as the x goes up by 1, the y value is going up by 2. That's what this rate of change means. Okay, 2 over 1. Every time I go up by 1 in the x's, I'm going up by 2 in the y's. So if I'm going backwards, so if my change in x is negative 1, my change in y needs to be negative 2. Okay, because that's going to simplify to give me 2. So 0 minus 2 is going to be negative 2. So my b value is negative 2. All right, so I got f of x equals 2x minus 2. That's my linear function. Okay? So we might need to work backwards to find our y-intercept sometimes. So we really need to understand this idea of rate of change. As my x goes up, my y goes up or down, depending on the situation. Okay? Definitely got some practice problems in your worksheet for that. All right, and then we got to remember this function of notation, this idea of function notation. So if I give you this linear function, g of x equals 5x plus 8, all right, the rate of change is 5. So that means every time our x goes up by 1, our y is going up by 5. Okay, so if I wanted to evaluate this function, g of negative 4, the negative 4 is playing the role of x. So every time I see an x, I'm going to plug in negative 4. Now, I just need to simplify this. Okay, 5 times negative 4 is negative 20. Negative 20 plus 8 is negative 12. So g of negative 4 is negative 12. If I plug in negative 4 for x, I'm getting out negative 12 for g of x, or y. Okay? In part B, we need to find x if g of x equals 64. Remember, g of x is just a fancy way of saying y. So here, the y equals 64. So I'm going to plug the 64 in for y, and I need to work backwards here to solve for x. Okay, I don't know what the x value is. I know the g of x value, or the y value, is 64. So I need to solve this equation. Subtract 8 from both sides. So I'll get 56 equals 5x. Divide both sides by 5. I'll get x equals 11.2. Okay? So we got to remember this idea of function notation. Solving for x or plugging in for x, depending on the situation. All right, make sure you do the practice problems. Let me know if you have any questions. Have a great day.